Standard deviation, as mentioned in the previous video, is a measure of how spread out your data is with comparison to the mean. By definition, standard deviation is the square root of the variance, but we like to use the standard deviation more because the unit that we describe the standard deviation in will be the same unit as your data. That will be clear a bit later on. So for the current math course, you will be expected to find the standard deviation using the GDC calculator. So I'll show you how to do that, but I'll also show you the formula so that you know how it works. So for example, if I have this data set and I want to use the graphic calculator for it, so first you're going to go to Stat and then to Edit, and you're going to put the list here. Now, in case you have a bit of data in your list, just go to the top and press on clear, not on delete, be careful. So press on clear, nothing's going to happen because you need to scroll down and then it's going to clear. Now, I've already entered the data set exactly here, double check your numbers. It does not have to be in order, but you have to make sure that all the digits are correct. Then you're going to go to Stat, Calc, and then the first option, which is one variance stats. You're going to put your list wherever it is. For example, maybe my list was actually in L3. So I'm just going to go to second and then L3 here, which is right above the number 3. But in this case, mine was in L1. So if there's a frequency list, as in if the data is set up as a frequency table, then you're going to put the frequency list, for example, it's in L2, that represents the frequency. In our case, we don't have that, so I'll just clear it. You have to make sure it's clear. And then you press on Calculate, and it's going to do the calculation for you. So the first one is your mean, the sum, and then the sum of the x values. And then you have two values here for the standard deviation, either the population or the sample standard deviation. We would like to use the sample standard deviation, so it's the sigma x here that we use. So 3.098, so to 3 significant figures, that would be 3.10. So the answer here would be, the standard deviation would be 3.10. Now, comparing standard deviations, we have, for example, if you have all these data sets and they all have the same mean, you'd notice how differently spread out the data is. So if you can look at these values for standard deviation, you can tell which one it relates to. The smaller standard deviation, the closer the data is to the mean. That's how we describe it. So the closest one seems to be data B, so that seems to be what 0.926 is. And the more spread out seems to be data C, so that's what 4.57 seems to be. So we can look at this. Now, using the formula, just to understand how the formula works, you don't have to use the formula in an exam, but in the case they use it for internal assessments, you'd have to know how it works. So let's say you have, we want the variance for 32 test scores. So you can see all the test scores here. You can organize it as a frequency table if you need to. And then first step that you need to do in order to calculate standard deviation is to actually find the mean. So you'd find the mean like usual. And then you want to calculate the distance from the mean. Now what I'm doing is I'm breaking down that big formula for the standard deviation that I showed in the first video. By breaking down the formula, you actually understand what you have to do in each step. So first we find the distance from the mean. So let's say the mean is mu here, so x minus mu, so we'll do 0 minus 5.25, so we get negative 5.25, 1 minus 5.25, that's going to be negative 4.25, and so on. And then because of the negative values, the point is you want to add up the values in the second column, but if I'm going to add them up and take the average of the second column. So this gives you the distance from the mean, so you want the average of the distance from the mean. But if you add them all up and divide by the value, what you're going to end up doing is canceling some values out, so you might end up with a 0, which is not a real value. So what we do is we square the answers just to make them positive. And yes, the numbers are going to be really big, but the whole point is to see the distance from the mean. And once you do that, then you find the average of this distance. So square together, the answer is positive. And by taking the average, meaning that you'll add and divide by how many data sets you have. So we could have done it here, add all the values and divide. So that would have given us the average distance from the mean. But then that would be inaccurate because of the negatives and the positives clashing. So in here, we'll have the squared numbers added up, divided by the total value, and then equal to the variance. So this will be the variance, but it's not the same unit because of the squaring. So what we do is we square root it and we get 2.49. So relatively, most of the data is close to the mean. 2.49 is not a really big number, but there's also a discussion on what do we mean by a big standard deviation or a small standard deviation. Once you have the standard deviations, sometimes we transform them. So we transform the standard deviation, variance, and the mean. So you can pause the slide and read it if you want to, but I'm just going to explain this through an example because it's best done through an example. So come back to this once we finish the example. Let's say we have a data set, you don't know what the values of the data are, and it has a mean of 14 and a standard deviation of 4. Now, we know that each value in the data set has 10 added to it. So obviously some values are going to change, mean, standard deviation, and variance. So this is what happens with the transformation. If I add or subtract a number, the mean will increase and decrease by that value. So if I'm adding 10 to every data set, so the new mean is just going to be the old mean plus 10. So I have 24. The new mean is going to be 24 for this new data set. But then the variance and standard deviation will remain unchanged, so the new standard deviation is still 4. For part B, each data set is multiplied by 5. This can also apply to, like, if you're dividing by 2, you can still describe it as multiplication. So then you need the new mean and the new variance. I could still talk about standard deviation if I want to. So what happens when you multiply? So you multiply the mean by that value. So the new mean is going to be 14 times 5. So that's going to be 60. And then the new variance, if you want the new standard deviation, it's going to be the same, but then the new variance is going to be the square. So by the value squared. So it's going to be 14 squared. Sorry, it's going to be the standard deviation is 4, which means the variance is going to be 16, because the variance is the standard deviation squared. So my standard deviation is 16, and then I'm just going to do 16 times the factor that you're multiplying by, 5, squared. Okay, so that's 16 times 25. You can also do the reverse. You can do 5 times the standard deviation, so 5 times 4, and then you multiply that by, you square that to get the new variance. So the new variance is going to be 400, quite a big variance. The idea behind this is that sometimes you might get a manipulation of data and you might not have all the data ready in front of you, so you need the old information to know how to transfer it to the new information. Sometimes you have a combination of the addition and the multiplication, so you need to make sure you know which one to use.